So control structures under labels, you can get this topic. Click on that. You will land on the control structure topic. We already discussed last class if block. So if block means just a true block. If your condition is true, then that if block of statements will execute. So if condition is not true, that the curly braces reason inside whatever the code is there, that won't execute for you. So condition can be either Boolean expressions or only Boolean values you can give. Expressions means between two variables, you can use greater than symbols. So whatever it is, logical operators, you can apply. Then directly you can give Boolean value also. Either of the way it is correct way to pass the Boolean value. So now, okay, sir, if what happens if there is a false condition? How I can test it? So for that we have a if else block. So if else block. So if the condition is true, if block code will execute. If the condition is false, you want to execute other block, that is else block here. The false condition block, if you want to execute, then else block is ready for you. You can use else block also to execute your false conditions. If a certain condition is true, then if block code will execute, else otherwise else block code will execute for you. So the syntax is this one. So if parenthesis, you will write the condition one time. If condition is true, it will go here. If condition is false, it will jump directly to else block. So that's the how code will, your cursor will move like this. If condition is true, only this block, else block won't execute. If condition is false, else block code will execute. So you cannot place any code here. So in this area. So the end curly bracket is the right. This is the if block. This is the else block. So the flow chart of if else is, if condition is true, this code will execute. If condition is false, this code will execute. Then if the if block is over, then it will come to out of the complete if else. If else block is executed, it will come out of the incomplete if else block. So that's the how code will, basically set decisions based on the condition, it will go that direction. The cursor will move to that direction. So here is the examples. Int a equal to 20, b equal to 30. If a greater than b, so now this block will execute. Else, this block will execute. So now in this above case, a value 20 greater than b value 30. So 20 greater than 30. True or false?
False.
False.
It will come to else block. Directly see cursor will jump directly to else block. That means if block won't execute. So based on the condition, the cursor will move to that block. Here you observe, if a less than b, less than b, and then b is big statement will execute. Else, a is big statement will execute. Now here a less than b true, right? 20 less than 30 true. So that means else if block only will execute here. If block will execute. So a few more examples I am giving, more expressions we are writing. So take int A equal to 40, B equal to 30, C equal to 100. If A greater than 10 or B greater than 12. So what is this expression output you will get? Can you tell me?
It runs the first one. If
no, what is the output you will get? I'm telling this expression output.
Okay.
What is this expression
true or
output?
false?
Hmm?
True or false? Either one of those two.
True or false? Which one?
True.
True.
It's true.
It's a true, right? You see, 40 greater than 10. 40 greater than 10 means what is the output? True.
True.
B greater than 12, 30 greater than 12, true. True or true? So what is the expression output?
True.
True. So true means this if block only will execute. Else block won't execute. Now can you see here same scenario? A less than 10 and B greater than 12. What is the output here?
False.
False.
So A less than 10 means 40 less than 10 false. And 30 greater than 10 true. False and true. What is the expression output? False and true.
False.
False. So it will come to else block. It will come here. So this is how based on the expression output. This expression you can write bigger expressions also. It doesn't matter. That's why you need to understand R and conditions. Logical operators, you must understand that. I have given tables. Follow the tables. So the developers will write this kind of bigger conditions. So when there are filters, in the filters place, they have to use this. The logical operators, they will use and or operators. Okay? No. That's sorry. If else. Next one, nested if else. What is mean by nested if else? So nested if else also called if else if ladder. If else if ladder we call that. So in if else statement you are able to test one true, one false block. But if I want to test multiple conditions, then what is the way? So if else block only test one true block, one false block. But if I want to test multiple conditions, only one condition you are checking here, but I want to check multiple conditions, then if else it doesn't help you, right? Such cases you can use nested if else condition. Multiple conditions if you want to check, you can use nested if else or if else if ladder you can use. If else if ladder you can use. So block of statements will be executed if the given condition is true in the if else statement. Otherwise else block of the statement will be executed. That's the if else. In if else statement, the block of statement will be executed if the given condition is true. Otherwise the block of statement will be skipped. So if want to execute the different conditions, different code based on different conditions, then we can use nested if else or if else if ladder. So that is the main advantage of this if else if ladder. So this always be executed from top to bottom. So first condition, if condition 1 is true, that statements will execute. If condition 1 is not true, it will go to condition 2. If condition 2 is true, condition 2 block statements will execute. That means statement is nothing but a code. If condition 2 is not true, it will go to condition 3. That's a sequence here, right? Like a waterfall, it will fall down. So it will go from top to bottom, all the conditions one by one will check. If all conditions are not true, there is a else block. So you have 5 conditions, all 5 conditions are not true, then there will be else block. So obviously else block means you need to understand if those are any one block is not true, it will go to else block. So that's this nested if else. You can see like this. If condition, so this block will execute. If it is true, if this is not true, it will go to second condition. Else, if you will write else, one space, then if condition. So this again, block. Block means curly bracket starts, curly bracket ends. So that's a else if. And so on, it will execute continuously till how many conditions you want to write, you can write all of them. At the end, you have to write else block. If all these conditions are not true, so what is the code you want to execute? That's the else block. Okay. Next, flow chart. If you see observe the flow chart, see, first condition 1 is checking. If it is true, code inside the condition 1 block will execute. Otherwise, if the condition 1 is not true, it will go to condition 2. If condition 1 is true, it will go to this code inside the condition 2 block. Then it will exit. Here also it will exit if block is executed. If condition 2 also not true, it will go to condition 3. Condition 3 is true, this path will execute. Condition 3 is false, this block will execute. Condition inside the else block will execute, and it will exit out of all the blocks. So this any of these blocks are not true, it will go to else block.
One quick question. If the condition 1 is true and the condition 2 is false, then it comes and it will check again true and false, right?
No, if condition 1 is true, it will directly go to here, right? It will exit. It won't go down again.
Okay.
So it won't go this path at all.
Okay, yeah, got it. If it is false only, then it will go. Okay, got it. Okay.
Yeah.
Clear.
That's a nested if else statement. You can see here I have given this is the bit complex structure. If condition 1, then condition 1 statements. Else if condition 2, condition 2 statements. See, you are writing multiple conditions. You are writing multiple conditions here. You can write n number of conditions. That's possible with nested if else only. Else, so false statements. If all these conditions are not true, it will go to this else block. So you can write, find out in ABC which one is big. How can you find out? So you need to write a program to find out in given ABC which one is big. That means you are going to give an input to the method ABC 3 input values. In that you have to find out which one is big. That means what kind of method you need to create? You have to give an input to this method. What kind of method you need to create?
The arguments?
Arguments, parameterized method you have to create. You want to give some input data, different input data. So you have to create a parameterized method. So you create a parameterized method and you practice this. If A greater than B and A greater than C, see that conditions, multiple conditions I am checking. Then I am saying A is big. Else, if B greater than C and B greater than A, I am saying B is big. Else, if C greater than A and C greater than B, then C is big. Else, invalid data. have to create a parameterized method and this entire code you have to write. That's it. Maybe if you want, you can write a return type method also here. So otherwise void method you can create. So try this, create a parameterized method. So this exercise for you. What are the three parameters? Int A, int B, int C. Three parameters you have to take and write the method name. So find out the bigger numbers in given three input. So that's a one program. That's a nested if else program. I'll tell a different program while practicing that. Switch case. Switch. The switch statement is similar to nested if else, but it will reduce the code complexity of the nested if else. So a switch statement will reduce the code complexity. You don't need that brackets, all those problems you can avoid with this switch case. Switch case is basically it's just a very simple block. Again, same as a other. It also checks the condition. Then we'll go to a particular block. So here you have a case by case. So switch statement is alternative for the if else if ladder, nested if else. You can use with the switch also same code. So I'm going to use this nested if else and switch case in our automation code. So make sure you are perfect on these areas. So the switch statement executes one block of statement from multiple blocks of statement based on the condition. So what the switch statement will do? Switch statement executes one block of statement from multiple blocks of statements based on the condition. So we have a number of choices. We can perform a different task for each choice. So like this, switch, variable or expression, case, value 1, colon, you write the code. Then you have to use a break. Break is optional, but better to use break. Then if case 1 is not true, it will go to case 2. Same, right? Same as a nested if else, right? Each case is there is one if else if condition. Each case is a one condition here. Each condition is we are writing in the case. So case value 2, then write that code. If this variable value equal to this case value 2, and this code will execute. Then break it. Break keyword, what it will do? It will terminate the entire switch block. It will come out from the switch block. So switch block started here, ending here. It will come out of the switch block if you break is encountered. If all these cases are not true, it will go to default block. In the nested if else, we have else block, right? That else block is in the switch case is a default block. It's almost similar, everything is similar, but a lot of complexity is reduced, right? Multiple curly brackets you don't need here. So code looks good. That's the advantage with switch case. So here the expression can be a byte or short, int, long, enum types or string types. You can write a string types here, integers, enum type you can write. Even wrapper class also you can write that. Wrapper classes means every primitive data type has one wrapper class. Byte. So you can differentiate that this is a class and this is the primitive data type. I'm saying this is a class, this is a class, this is a class, this is a class. Here integer is a class, but how you can differentiate a class and primitive data types?
Naming convention.
Naming conventions.
Init cap.
Exactly. Naming conventions. See, the class means first letter, cap letter. So one word, right? That's why B capital. This is the wrapper class. So byte primitive data type is a byte wrapper class. Short primitive data type has a short wrapper class. Int primitive data type has a integer. This is int, no, wrong, integer wrapper class is there. Long primitive data type has a long wrapper class. Basically, these wrapper classes are used to convert the primitive data into object into primitive format. That you can achieve with the wrapper classes. So that's why this wrapper objects also you can define in the switch case. And you can create any number of cases in the switch statement. The case value must be literal or constant. The case value should be a type of expression or variable, anything. Each case should be unique. There is no duplicate cases. If you create a duplicate cases, it will throw compile type error. Each case has a break statement, which is optional. It is used inside the switch to terminate the statement sequence and jumps the control to the after switch block. If a break is encountered, the entire switch block will be exited. So that's a break statement. If break is no, it will terminate from there. It won't move to next case. If that case is true. So there is an optional default cases then that must be placed at the end of the switch statement. If none of the cases are true, then this default case will be executed. The default case doesn't need a break statement. You don't need a break statement for the default cases. This is the flow diagram. You see, you can understand easily by seeing the flow diagrams. You see the arrow marker, it is very pointed very clearly. Switch. So in the switch variable or expression, you can write if case 1 is true and if this variable matching the case 1, and it will execute that code inside that case 1. Then it will encode the break and exit the entire switch block. If case 1 is not matched, it will go to case 2. Case 2 is matched with this variable value or expression, and that code inside that case 2 will execute, then break statement will execute. So then it will terminate from there. In case 3, 4, and case n, if it is matched, this code inside that case n will execute, then break will encounter, entire switch block will exit. If all cases are not true, it will come to default. So default is a final, and you don't need a break statement in the default, and it will exit. So this is all the things. So I just giving one example here. This you practice, and I'll explain different program. You need to find out, the user will give an input to this method, and you should tell that whether it is a character or whether it is a consonant or vowel. How can you tell that? So that's the program we are writing here. See the programs, all methods, public static void, find char or vowel, character is vowel or consonant. So you are giving an input character, data type of data you are giving for this method. Then you need to tell this character is a vowel or consonant. So switch to this character. If the switch case A, if the given character is A, system.out.println, enter character is a vowel, you are saying, then break it. I cannot test all 26 characters. If I test vowels, 5 vowels, right? 5 vowels, if you test, automatically other than 5, anything you enter, that's going to be consonant, right? So that's what I'm doing here. See here, 5 cases I have written. See case 1 A, case E, AE. So if this entered character is equal to E, then this block will execute. So if that is not true, it will go to next case. If entered character is I, so then this statement will execute. So then break it. Case O, then system.out print entered character is a vowel, and then so this will execute. Break. Case U. So any one of them, A, E, I, O, U only I'm thinking. If all these are not true, entered character is not equal to any of these A, E, I, O, U, it will come to default block. I'm saying entered character is not a vowel, then I'm printing that character. What is that character? So that's it. Then end the switch block, end the class. This is all about conditional statements. So what are all the conditional statements? If else, nested if else, switch block. So these are all the conditions. And let's see, and we'll write the. So I'll just stop this.